I'm here this morning on behalf of Total Data Center Solutions to try and help educate you and or enhance your knowledge of battery energy storage systems and on-site, near-site generation. Hopefully, by the end of it, you'll be slightly wiser, slightly savvier, and slightly more interested in pursuing it for your own purposes, either in a data center or any large user of electricity here in the UK or in Ireland. So let me crack on. So just a little bit of background. I'm not going to deep dive on anything because we've only got a half an hour here, and I'd rather go broad and informative rather than deep and technical. So the essence of this slide is just to say that battery energy storage is both an incredibly important element of the UK generation distribution and in Ireland systems, and will grow exponentially over the next decade or two. They're talking about just in the UK and Ireland needing 25 to 50 gigawatts is the newest one. And old Elon Musk, for all of his shortcomings, gave an interview a number of months ago before this whole Twitter thing started to grab center stage, and said that he and his team had done a worldwide study and there was going to be the need for 3 terawatts of stationary battery storage worldwide. So we're talking about an industry sector that is getting big, will be gigantic, and will be fulcrum in helping transition us to the next stage of the rise of renewables. So just a quick background, a little bar chart to show you how things are growing in the UK and Ireland. You'll look that there was the bit of a pandemic dip between 2018 and 2021. But the figures aren't in for 2022, but I expect a substantial increase on that. The only other granular element of this is that if you look at the purple elements of the bar charts, you will see the exponential growth of that color purple, which represents projects that are more than 30 megawatts in size. The size of these projects has grown, again, exponentially in the last couple of years due to the economies of scale and the overall need for just the enormous amount of battery energy storage needed here in the UK. This one we won't dive into too deeply, but just to say that there's a really interesting takeaway from this one. If you look from the magenta, the burgundy color out to the light pink, you'll see where the transmission network can address a number of the grid services that are required to keep these renewable grids stable and operating. You can see that the lighter red, the more local network, can do a handful more, but it's really only battery energy storage in the circle in the light pink, which makes battery energy storage a bit of a Swiss Army knife in terms of the services that it can deliver across the range of the grid. For you folks that are involved with data centers, either owning them or operating them, you can look the quadrant or third part of the circle, the outermost circle, is the services that they can be delivered into your facilities and the benefits that can accrue from them. So everybody loves a good acronym, and the battery energy storage industry is no different. So a number of years ago, the acronym BESS was coined, probably about 25 years ago, maybe longer. And that stands for Battery Energy Storage System, nothing more, nothing less. In the UK and Ireland, and more pervasively around the globe, there are 2 flavors of BESS, which is, one is known as behind the meter, which effectively is co-located battery energy storage, which I'll dive into a bit deeper in a moment. And the second one is called grid scale, where independent battery farms, generally quite large, are located directly adjacent to a transmission or local network operation substation and deliver services directly to the grid, rather than behind the meter, where they're located adjacent a big user of electricity. Let's say that's a big data center, a hospital campus, a manufacturing facility, a big refrigerated warehouse, university campus. Any group that's using substantial amounts of electricity are prime candidates for this, and hence the data center business is just a true prime candidate. So future of the energy storage business, if you, the behind the meter developments are moving apace. Just in the UK, I'll jump onto it in a second, but I believe there's, as of 2021, there were 317 projects in flight or operational. There's probably at least that many again for 2022. The figures will come out early in Jan, late in Jan. But suffice it to say that the trajectory is reaching what all of the promoters of private early stage companies show is a hockey stick. But I've got no vested interest in showing it as a hockey stick, but trust me, it's going to look like that in the next couple of years. So benefits of battery energy storage. And if you put your data center hat on and say, why would I even bother looking at these things or determining whether they're right for me? Effectively, because they are located outside your facility, they are plug and play, containerized, fully automated battery energy storage systems. There's no interruption to your power supply. And suffice it to say that although it took a bit of work, we were able to convince all of the big data center operators that they're genuine, and particularly their electrical engineers and designers, that we as structurally pose zero, as close to zero risk to your power delivery supplies to your racks and cooling systems, etc. We add an additional layer of backup and resilience, although we've chosen quite consciously not to refer to ourselves as a data center or major facility UPS. We can effectively operate as such and thereby overlay an additional layer of resilience to your normal configurations, which would generally be around the Uptime Institute, Tier 1, Tier 2, 3, 4. So if anybody who wants more details on that, I'm happy to provide, but we won't dive down on that one. So it's non-disruptive, it sits outside your facility, it's completely self-contained, it's got its own air conditioning, its own fire detection, fire suppression, transformers, bidirectional inverters. Everything is contained either within the containers themselves, or in some cases, we put the transformers outside them in order to be able to get more energy storage into the containers. It gives you flexible, secure, and dynamic charge and discharge processes, which I won't bore you with because they're quite technical, but suffice it to say, it's a way to both make and save money by optimized and clever operation of the battery systems. The way that we do it, which I'll explain in a second, generally we can save we'll call them a host, not a customer, because we're not selling them anything, but you as a data center host for a battery energy storage system can save somewhere between 5 and 10% a year on your annual electricity bills, which if you probably look at the most recent ones, given the last raises in October, will be eye-wateringly expensive. So effectively, that's a 5 to 10% savings. You've got access to the latest technology delivered in an as-a-service method, plug and play, which makes life really easy in terms of how we do it, but not easy in terms of the operation, which we know how to do. We help decarbonize the grid, which I will explain to you shortly. And you get, and this is probably really, really an important takeaway. There are material carbon savings per year for every megawatt that we deploy on a host site. And I'll refer to that, the details of that in a moment. So like anything, the acronym BESS Plus is actually a term that I invented about 3 or 4 years ago, and it's now becoming quite widely used in the industry. BESS Plus is effectively, at its core, a battery energy storage system, and that coupled with on-site, near-site solar generation, sometimes wind, although it's a little bit tricky for onshore these days. CHP alongside the battery energy storage in concert with the solar. CHP is a great interim solution for generation in unstable networks. The problem that we've got with that at the moment is that we would normally use gas-fired generators, and the price of natural gas has just murdered the business case. But we remain incredibly hopeful and optimistic to be able to use hydrogen or part hydrogen as a solution to natural gas. The beauty of data centers specifically around on-site CHP is, one, you're used to it in any case with diesel generators, but two is with green hydrogen, although it's still moderately eye-wateringly expensive, because data center gensets are run so seldom in anger and for relatively short periods of time, the fact that the fuel is extortionately expensive in the big picture doesn't really matter, because your carbon footprint associated with that generation is zero. Again, we can additionally add on to our Best Plus offerings, EV charging, which can be quite a nice feature at your data centers, office complexes, and or industrial facilities, because the EV charging, we can do both domestic cars and larger vehicles. So Best Plus, with just a quick little recap, we've got behind the meter BESS, we've got behind the meter Best Plus, and then we're going to go on to grid scale. And grid scale are generally large, effectively farms of battery energy storage system that are, in layman's term, daisy chained together to create a giant single battery, which is then used to work to provide grid services to help stabilize the grid and to get paid to do so. So I call this, kind of tongue-in-cheek, the manic depressive Irish and UK grids. The little simplistic, naive little drawing there will show a very simple, on your left, you'll see power generation. You will see very large pylons, which is the distribution network. They then drop down into the transmission, more local transmission DNO networks, and they are used to supply electricity to industrial facilities, to residentials, to cities, et cetera, et cetera. And when the original UK grid, in fact, this is a worldwide problem, when the original electricity grids were constructed, they were constructed under the premise, and what they believed would be an immutable premise, that you would build a relative handful of absolutely massive generation facilities. And here in the UK, they're kind of household names. You got Didcot, you've got Fawley, you've got Uskmouth, you've got Drax, you've got the rest of them, handfuls across. You basically build those, turn them on, and run them for 30, 40 years, 24 hours a day at 230 volts, 50 cycles, and the grid just hummed away happily with only tiny tweaks to take care of both intraday demand and seasonal demand. So it was a very stable, a very unipolar grid transmission. And like many things in life, in the early days, it was a lot simpler. So we've moved to the manic depressive phase, where if you look at that map, both of UK and Northern Ireland, you will see points and blobs of generation. Almost all of that is intermittent generation, and they either produce a little bit of electricity, no electricity, or a heck of a lot of electricity. And as that electricity either surges into the grid or is drained from the grid becomes inherently unstable because of the push-pull associated with unpredictable generation. And what that does is it creates havoc, complexity, and cost for the grid operators. And ultimately, there will be the need for a brand new super grid, which is already under consideration in design, and in some places is already being installed. But in the interim, the only real viable buffer to smooth out that instability is battery energy storage. There are things like pumped hydro and a few other things, but realistically, battery energy storage is the only practical method of getting us towards a renewable grid without suffering outages, what I call wobbles on the grid, which is not a blackout or even a brownout, but a wobble in the frequency, which we as residential consumers don't really notice. We notice the lights flicker, but we don't think too much of it. But if you're running precision machinery, if you're running data centers, all of that, it can have a massive impact. So the manic depressive grid, coupled with the rather colorful changes in the electricity price, particularly in 2022, have created kind of a perfect storm for data center operators, grid operators, and for the general public in terms of trying to figure out how we're going to pay for this new material reset of pricing. In the lower red area, you'll see this kind of, if it was a medical EKG, they'd say, patient, you're fine. As you get into 21 and 22 and you look and think, ooh, something's really not right here. So prices have gone from, let's say 3 years ago, from 40 pounds a megawatt hour, and they've crested at almost 600 pounds per megawatt hour here in the UK. They've currently dropped back to about 260, but still that is 4, 5, 6 times more expensive than it was just a few years ago. And for those of you who are getting your electricity bills and thinking this cannot be right, and then doing the due diligence and finding out it's unfortunately right, you'll know what the pain's about. And if you can imagine the data center bill coming in, there was a data center operator in East London, most of you will know the name of the firm, but they were burning, 4 years ago, they were burning 28 million pounds worth of electricity. And I put a note into a colleague of mine who's quite high up in the operations team to say, any chance you can share what your bill was for what will be for 2022? And he just wrote back 2 words, don't ask. So, I mean, you guys are all probably watching this. Battery energy storage systems can deliver 5 to 10% savings, and which is a huge physical number when as it drops to the bottom line. So do keep it in mind. The only solace that I'll give you is if you look at the little kind of half circle on the right-hand side, you'll see that although we think we're suffering terribly, if you look across a number of other countries, they've had it a lot worse. And I guess most surprisingly, at least for me, is that France, which is like nuclear generation central, I would have thought would have been immune from this, but apparently the pricing changes have coincided with a bunch of their nukes being down for routine maintenance and or closure replacements. So changing gears a little bit, we've got carbon reduction. The deployment of battery energy storage here in the UK, based on its daily fluctuation in carbon intensity, and when I say that, I'll try and explain it, which is if you look at this graph, you'll see the white line that squiggles up and generally up to the right and then gently proceeds down. And effectively, it's a representation of the carbon intensity of the grid across a 24-hour period. And what happens is in the middle of the night, when the demand is low, there's lots of wind generation, etc., the carbon intensity of the grid tends to drop quite precipitously. This indicative one is just kind of a general day, but it ranges in a huge range. So what happens is in operating battery energy storage systems cleverly, you charge them up in the middle of the night when electricity is not only least expensive, and in some cases, they actually pay you to take the electricity off their hands. But as importantly, and in some cases more importantly, it charges up when the UK grid is at minimum carbon intensity. As people wake up, so the battery's fully charged, it's sitting there ready and waiting to go. As people start to wake up, as kettles go on, as lights go on, as showers are taken, etc., you can see it starts to creep up. People then head off to work, it then slows down, and then you get the big pop generally early in the evening when everything goes on, both domestically and certainly remains on in manufacturing, office buildings, et cetera, et cetera. So it's at that point the batteries are discharged. And by operating those in that way, because the battery is discharging at peak carbon intensity and thereby displacing an element of that high carbon generation, which is normally gas peaker plants. Sometimes it's actually turning coal plants back either on or up in terms of their generation. For every megawatt that we deploy and operate using basically the methodology you see on that graph, we can save more than 40 metric tons of carbon each year for each megawatt that we operate across a year period. So it is a huge, what used to be an ancillary benefit, and I say that when we started this 5 or 6 years ago, and we'd say we can save you cost and carbon, a major user would say, tell me about the cost, tell me what I can save. Oh, the carbon's cute and maybe my sustainability people will like that. It has flipped 180 degrees. And when we say cost and carbon, particularly at sea level, they say, tell me about the carbon. And I'd also like to know about the cost savings. So it's been a 180 degree shift from when we started and the perceived and actual benefits of that carbon savings by cleverly operating the battery energy storage systems. So if I've piqued your interest in terms of battery energy storage, BESS and BESS Plus as potentially beneficial to your organization, please, happy to share as much as both I can and certainly my more technical work colleagues can in terms of how they might be able to benefit you, and we can quantify that in a very meaningful way. But just wanted to warn you, although you can probably, if you get lucky and in a couple of years' time, as you achieve enough expertise to operate the batteries and solar systems effectively and with skill, you probably can make a bit more money. But you won't make any more carbon benefits, because when we do it, we actually allow the host, meaning yourself as data center owner operators, to capture 100% of that carbon benefit and still be able to save you 5 to 10% on your annual bills. So I just wanted to point out that this is not an easy business. And although data center operators and owners are pretty good at big constructing at scale and operating at scale, it's still a different business than what you are used to. And as a consequence, the more DIY approach you might want to take, the greater the inherent practical risks there are associated with that, the operation of it. So I won't go into great details, but happy to share it secondarily. But do understand this is not a simple business. The technologies are very robust, so they don't tend to cause a problem, but the operations and keeping up with the endless regulation changes that occur in the grid is more than a full-time job. So what do? Energy Optimization Solutions is our development delivery partner. They are the ones that actually design, build, own, operate, finance, own, and operate these BESS and BESS Plus deployments. It is you, if you look at this, what do you call it, diagram, it shows effectively you as the host would have your own facility down on the left, your own electrical distribution areas, obviously a meter, and your own connection in the case of data centers, connections to the grid. But all of the equipment and operation of the stuff that's in the green brackets is all financed, owned, and operated by Energy Optimization, and as a consequence is a true zero capex, zero opex solution for you as data center or large consumers of power. So site criteria, just in case you're interested and want to know more. And I think if you're involved with data centers, each of those, you'll be able to tick each of those boxes. So, or each of those circles. Are you an energy intensive business user with a consumption of more than 5 gigawatt hours per year, or spending more than about 650,000 pounds or euros per year on power? If you're a data center operator, you know how much bigger your power bills actually are. Importantly, do you own the freehold of the site or have at least 15 years to run on the lease? Because the contracts that we deliver are 15-year contracts for Best and Best Plus solutions. Have you or can you access half-hour consumption and data for bills? Most of you, your procurement billing department will have this, or certainly your electrical engineering groups. It's not hard to get a hold of. Would you like to reduce your energy costs? That's probably quite rhetorical. Would you like to increase opportunities to reduce carbon emissions and help decarbonize the grid? And again, I go back to battery energy storage as a delivery system are absolutely imperative to the future of the UK and Irish grids because of the rise of renewables on the grids and the way they're currently operated and designed. And the fact that you as host can capture 100% of the carbon savings associated with the operation of that battery is quite a bonus. So I'm going to back up and kind of broaden the brush for a second, just to share a couple of things. In terms of innovations in energy storage, both on the battery technology and chemical composition, materials composition, there's all sorts of things going on, mega interesting ones. We keep quite close track of it. Many of them show incredible promise, but at the moment, and probably for at least the next 4 or 5 years, lithium-ion technologies, and particularly lithium ion phosphate, are the only true bankable solutions. Meaning if you're looking to finance this, they're the only, because they're so well developed and so well understood, and their degradation is so well understood and improves all the time, the manufacturers can offer warranties and deliver on those warranties that allow one to construct a business case on a risk-adjusted basis to make sense of a long-term commitment to that technology. Anyway, there'll be lots of cool stuff coming out, so watch this space. On the further end of the energy storage space, there's a number of things. You can see this Finnish heat battery, which is a sand battery that they use to store heat at 500 degrees C and deliver it when it's needed, either for residential or industrial processes. There is an Australian group called 1414 Industries, and 1414 degrees C is actually the melting point of sand, but they use the hot sand or very hot sand to actually create electricity. So they store it as heat, but deliver it as electricity. So that's one to watch, not particularly applicable to data centers, but an interesting innovation. You've got what's called a Swiss water battery, which is, given the fact it took 14 years to build, must have more to it than that, because I would just call that a hydroelectric dam. But knowing the Swiss, there are several bells and whistles that they've built into this thing to make it much more than just a hydroelectric dam. Again, just for interest. Innovations, we've now got the first of the hydrogen trucks coming on, and some of them being built in the UK. I raise hydrogen as a fuel, one which I raised earlier, because green hydrogen could truly be a game-changing fuel for the data center industry to replace diesel gensets. And again, given the fact that they use relatively so little, rather than running something like a truck, which is running 12 or 15 or 20 hours a day. These, as we all know, gensets run a couple of times a quarter and maybe once every 3 or 4 years in anger to help support the data center itself. The other cool part about battery energy storage at grid scale is because offshore wind, which is one, not the price of the electricity, but the equipment is just eye-wateringly expensive. The offshore generation are actually told to shut off, or what's known as curtailment, generally in the middle of the night when it's blowing a hoolie in the North Sea and off into the Irish Sea or off the North Scottish coast. And at the time that they can make the most money, the grid tells them to feather their props and shut down, which is, if you're an owner financer and you spent billions and you think, hang on for a second, this is my one time to make a shed load of money and you're telling me to shut off? So battery energy storage, rather than curtail the wind, could absorb all that vast amount of electricity at incredibly low prices and utilize it, putting it through hydrogen electrolyzers to create a vast pool of relatively cost-efficient hydrogen for use in data centers and in industry. So keep your eye on that one. That could be a game changer. It's not, as they say in Devon, it's not a 5-minute job to be able to get that done, because the offshore wind takes a long time, and so does the hydrogen electrolyzers, but it's definitely one to watch. I'm going to run out of time here, so I'll keep it quick. Again, if you get a chance, jump on Wikipedia and put in supergrid. That is a very high-level view of a future potential supergrid for Europe, North Africa, and over into the Middle East and out to Iceland. It's a fascinating architecture and possibilities. I can't imagine how much it's going to cost if they're ever able to do it, but at least people are thinking ahead, and that's what matters. Again, this is a little one, but My Grid GB is an online resource that if you're interested in board one day in the winter when it's raining and can't get out, put it up on your browser and have a look. It actually shows the composition of the British electricity generation grid, and it's just an interesting thing to see how it morphs both over a day and from season to season. Takeaways, we'll keep it simple, just really important. BESS Plus is important and growing fast. BESS Plus is complicated and a tough DIY endeavor. BESS Plus can deliver more than 40 metric tons of carbon savings every year for every megawatt we deployed. And we have almost a gigawatt of projects in flight, so that's a lot of carbon. Using the EOS BESS Plus method, you as a BESS host can save 5 to 10% a year on your electricity, and all of the responsibilities and all of the operational and insurances, everything, reselling, it all comes down to energy optimization, and you still get to capture 100% of the carbon benefits. The UK and Ireland need vast amounts of additional grid scale and behind the battery capacity to meet our net zero requirements and commitments. And innovation is alive and thriving in the BESS Plus space.